Bear with me, having technical difficulties here. Good day, everybody. Welcome to the Robot Builders Night Virtual. Today is July 16th. And this is not cooperating at all. Today's July 16th, and we have our regular weekly talk, robot-related stuff. We do this remotely every Tuesday night at 7:30 p.m. Central Time, I believe it is. We go around the table and we listen to everybody have a repeat. To let us know what's happening with their robot projects and ad hoc discussions or questions for the club, and sort of see if we can stump us on a challenge. If you have any questions you're having a problem with, otherwise it's just a chance to hang out and listen to what other people are doing. We record these meetings. If you don't want to be recorded, keep your video and your audio off, and you won't appear anywhere in the videos. With that said, we have John to kick us off with an update on his robot.
Right. So I've spent the last week pretty much working on my my outdoor rover for Robo Columbus, which we're hopefully going to be holding here up north this fall. So I've done a bunch of work to it. Right now I've got my GoPro mounted on top just to capture video while I'm rolling around. So this is the board that I built is set up and running right now. I've got my Raspberry Pi running. I've got my Oak D camera working. I'll show you a couple things here. So what I'm doing right now is I'm rolling I've got the vehicle running under RC mode, and I've got the Raspberry Pi 4 running and capturing data from the depth, from the Oak D Lite depth data and video frames. So here's a couple frames showing. When I'm rolling around right now, I'm definitely going to have to be kind of ignoring the bottom quarter or so of the screen. So this setup with the Oak D Lite is really cool. Depth AI allows you to do some neat things, and I'll show you the code for that in a minute. We can talk about it. But here's another image showing when I'm relatively close to something. You can see it's not perfect by any stretch, but you get a lot of data back. And here's one where I'm sitting stopped in front of a tree with a chair leg kind of thing. So right now it's set up so that it only highlights these little squares when the median value is less than a meter away. So anyway, that's that. So let me stop sharing. And so you guys can probably see this if you pin my chat. So let me move it here. So, you can see I can turn the steering wheel with, I can turn the wheels, and I can, and the interesting thing about this, I mean, although this started out life as an RC car, I'm not actually, it's running in RC mode, but it's actually channeling the data from the receiver through my STM32. And I've got a MicroPython application running on that. And let me show you what it looks like. So this is the application here. So it's basically, I mean, there's a bunch of stuff in here. You know, I set up a bunch of constants for where everything is hooked up, and I have a bunch of things commented out that I'm not using yet. But the main thing that I'm using here, I've basically got these two decoders, which are servo decoders. So those that's a class that basically reads in pulse width modulation data from a source, and in this case it would be the RC receiver. So the RC receiver has, you know, this one has 6 channels, and I'm using 2 of them, the steering and motor, and it outputs an RC signal in PWM. And so the servo decoder basically takes that signal and you know, converts it into a pulse width. And if we look at the class, it's basically using a hardware timer and an interrupt callback. And on a rising edge, we start the capture and capture a timestamp, and then on the falling edge, we compute the pulse width. And so from that, we can basically say self motor decoder pulse width at any point in time, and that is whatever the current value is. And so I'm passing that as an input to the motor servo's position. So the motor decoder is hooked up to channel 2 on the receiver. The motor servo is basically a servo object that uses PWM to control the motor in this case. And the same thing for the steering. The steering decoder is indirectly hooked up to the steering servo, because I'm just sitting in a tight loop running at basically 50 hertz. It doesn't really matter what frequency I run at here, but I figured since the servo runs at 20 hertz, I might as well. Actually, I think the servos run at, yeah, it's 50 hertz, sorry, because I'm waiting 20 milliseconds. So I'm basically passing in the decoded values for each of the servos. And the servo code is really simple. It basically creates another hardware timer with the right prescaler such that you can set the pulse width to the microsecond value that you want. And the servo decoder passes back microsecond values, so anywhere from about 500 to 2500 microseconds. And so that's what this ends up returning. And so I basically can take the output of the decoder and punch it into the servo, and it looks like I'm controlling it directly, but it's actually going through the STM32. And so the idea is that I've got my my little wrist-mounted URC, and I'll be able to switch modes from autonomous mode to RC mode if I want to drive the car around manually in that. And so this was just my sort of my proof of concept that I can actually drive the car around while dealing with these values. So the other interesting thing that's happening here is the Raspberry Pi is running. And I've spent a bunch of time looking at Depth AI, which is the library that Luxonis, I think it's their library basically, and for the Oak D Lite. And it turns out that it's a really neat and very powerful mechanism, these pipelines that you create. So you create a pipeline you create a node on the pipeline for the RGB camera, which is the one in the middle. It's a color camera. And then I create the left and right mono camera nodes. Those are basically monochrome cameras, the stereo ones. And then I create a stereo pipeline, which uses those as inputs, because I link the left camera's output to input into the stereo node. So you can think of it kind of like these things just feed into nodes. And then I create what's called a spatial location calculator, which is what draws all those boxes that you saw in those videos. Basically what it does is it gives you regions of interest, and you can specify the region of interest, each one of them. In this case, there's 16 by 10, so I'm making 160 regions of interest in this thing. And I'm basically telling it, hey, here's your region of interest, a rectangle, and in this case it's a basically a rectangle in the 0 to 1 range for X and Y, and for an algorithm, use median, which is the sort of the depth, and then I add that as a region of interest. And then I basically take the stereo camera and input the depth into that as well. And finally, I create a sync node, which basically sets up the timing such that the nodes from the stereo camera and the nodes from the center camera have the same timestamps, within, you can specify it within 50 milliseconds in this case. So then I create an output node, and basically that whole thing, when you run this piece of code right here, that basically pushes that entire pipeline onto the OAK-D Lite. So all that code that you've used to set up these objects, they all get pushed onto the OAK-D Lite. And then I basically build a queue that allows me to retrieve data from the OAK-D Lite. And you can retrieve just a small amount of data, like the metadata, which is like 160 large blob pixels that have depth. And I do retrieve that, and you can also retrieve, actual OpenCV image frames. And so I get the spatial locations and I get the CV frames. And then I walk through the spatial locations and extract the depth information from it, find out what the distance is, and then if it's less than a critical amount, then I draw it in red, and if it's less than a warning amount, I draw it in orange. And you basically, this is basically just a copy of the code pretty much from
I can't hear John.
I was going to say, am I the only one that lost him?
Nope.
John, we're not hearing you.
We lost them too.
So do you think he's reading the text? Yeah, you might see it pop up.
He's talking.
I think he saw something.
We might have his attention now.
There he goes.
Still not hearing you, John.
Can you hear me now?
Yes.
Yeah.
Oh, that was weird. Did it just drop out, or?
Yep. It just dropped
Okay.
out. And
About a minute and a half ago, 2 minutes ago.
Yeah.
Okay. Anyway, so the idea is I'm going to be able to drive the car around in my backyard and in a park and whatever, and gather this data that will get saved. And this thing, I've got a 1 terabyte SSD right here, which is hooked up to my USB hub, and the OAK-D is also hooked up to the USB hub, and they're actually plugged into the Raspberry Pi 4. And it's a powered USB hub, so it's not providing power for those things. So I basically write an image from the camera that contains both the color image and an overlay of the region of interest data every 1/10 of a second in this case, as well as appending a line to a text file that's synchronized. I use a millisecond counter, and I put the same value into the text line as I put as the file name for the PNG frame, so that I can go and find an interesting image, and then I can go and find the line in the text file that has the actual data from the camera, from the depth data from the camera, and then I can figure out what's going on, hopefully, and tune this stuff up and start using this for actual object obstacle avoidance. So yeah, that's what I've been working on.
Yeah. So John, my limited experience with the Oak D light, the depth didn't work well. It worked really good from 1 meter out, but somewhere between, it doesn't have any really good close depth.
Yeah, it's about 20 centimeters is where it cuts off. 20 or 25 centimeters. That's what the spec says. If you go and look on the Oak D light specifications page, it'll tell you, it can read out to about 8 meters or 6 meters or whatever. I think it's 6 meters. But the closest it can read is about 20 centimeters. And closer than
Seemed
that.
it seemed like I was getting like worse than that, but.
Well, I did a little YouTube video on my channel, and I'll just drop a link to that since YouTube really sucks on me. I'll drop a link to that in the chat. And that's basically my hand moving in front of the camera, and you can see where it gets, close to about 20 centimeters, and then all the little boxes disappear as my hand gets a little bit closer because it stops being able to tell anything at that point.
Okay.
So my code, if you want to look at it, is I have it's sitting in my repo, both the code running on the STM32 and the code running on the Raspberry Pi. And so it's in a new repo that I created, which I just dropped in the chat there. So the STM32 code is in the STM32 directory, and the Raspberry Pi is in the Raspberry Pi directory. So that's all out there if you want to look at that.
Are you using Pi OS or like
Yes.
a version of Ubuntu?
No, I'm using Raspbian, the latest version. So yeah, seems to work okay. Can't complain.
And I think your code that measured the pulse width was running on the STM. Is that correct?
Yeah, it's running on one of these. So this is a this is a WeAct board from WeAct Studios, which is basically a place that sells on Alley. It's like about I think it's $11 Canadian, so it's probably about $7 or $8 US for this, and it's an STM32 F405. So it's basically very similar to a Pi board. And I mean, if you actually, this is a Pi board and this is that board, and you can see there, the main difference between them is that this board gives you a lot more GPIOs because it's a double row board. So you can't use it in a breadboard, but like a solderless breadboard, but it works fine if you build a PCB like I did. And this is the
thing I wanted to ask
PCB.
about was getting a interrupt into MicroPython and code to do that. So I was just googling it, but I guess
well, if you here, I'll bring it up here again for a second. So in MicroPython, so if you look at, say, servo decoder, so I'm basically, and this stuff is specific to the STM32. Some of this stuff, like the timers work a little different on an STM32 than it does on most of the other boards. But basically, we're creating this IC, and it's basically a timer channel. So we're basically creating a timer that's connected to a pin, and we're capturing rise and fall. And you can do the same thing with, if you've got an ESP32 or an RP2040, you just say machine.timer, and you can say specify it's for rising or falling or both, and you set a callback. And so the callback is literally just a function. And the function takes the timer as a parameter, although you don't normally have to use it. But the important thing here is that we're checking the value of the pin that you specified as the servo. So, as you know, PWM pins, it goes high at the beginning of the cycle, and then it stays high for between, and classically it's 1,000 to 2,000 microseconds, but it might be like as little as 500 microseconds and as much as 2,500 microseconds. And then it stays low until the end of a 20 millisecond, which is like 20,000 microseconds. So it stays low for the rest of that thing, and then it starts another cycle. And so we're basically, if the value is 1, basically if self IC pin dot value, so if it's high, if the pin is high, then we're starting the pulse, as it says in the comment here. It's a rising edge. And so I basically capture the timer value, which is what this IC dot capture is.
I get that. I get that
Yeah.
logic. The thing that I hadn't realized is that I guess everybody who provides a MicroPython port to their board or processor also provides objects or libraries in the port that deal with their particular hardware and how their timers work and enable you to hook interrupts up to it and such.
Yeah. I mean,
That's the
How about
machine.
that?
That's the machine. The
yeah.
machine files.
Oh,
This
so
this stuff up
there's a
here.
well-known
So,
object class called machine that.
well, it's the main thing in MicroPython is machine that has, it's got pin and it's got ADC and it's got I2C and SPI and UART and a whole pile of other things, timers. And so if you look at my URC code, for instance, the touch manager, it's running on an ESP32. So I basically set up an interrupt. I set up a pin, but then I also set up an interrupt handler, and this is how you do it on ESP32 or an RP2040. You basically just set an IRQ, and here's the handler as the callback, and in this case,
machine's got the touch object in it.
what's that?
Machine has got the touch object.
No, this machine is just about things like pins.
Oh, so touch is another class that.
Well, so this is the touch driver. Okay, it's a CST816 chip in the little board that WaveShare sells. So this is it's basically an I2C thing, and I set it up in here. I build the CST816, and so that's the guy who actually triggers this pin. So the CST816 is an actual chip, and one of its pins, its interrupt pin, is connected to the touch interrupt pin on the ESP32, which is pin 5. And so I'm basically saying when that pin changes, in this case, when it's a rising interrupt, then trigger this callback.
Cool. Thanks for that explanation. I didn't know. Had never come across code that did that kind of stuff in MicroPython. So interesting.
Yeah. Yeah, so I mean, I've had a lot of this STM32 code written for several months now. I've got little classes written for each kind of object on this robot that it needs to talk to. So it has a quadrature encoder, so I have an encoder class. It has a 9-axis IMU up top here, so I've got an IMU class. It's got the servo decoder and the servo code, and I think I've got a few other things as well. I don't remember all of them, but they're yeah. So basically, I've had those little modules written for a long time because I was able to test them individually, but I've just recently created my sort of main that's starting to tie all this stuff together. And of course, just recently started playing with the Raspberry Pi on it too.
Cool, thanks.
John, are you having any difficulties with encoder interrupts and
No.
like your RC pulse interrupts?
The STM32 is phenomenal at that. It's the one thing. Like for instance, the encoder, and this is the really beautiful thing about the STM32. I'll show you my encoder class. Where is it? Encoder. So the STM32 has built-in hardware for interfacing with quadrature encoders.
Oh, yeah.
So you can set with the PYB timer, you can set encoder AB, and it has to, you have to specify which channel it's on and that sort of thing. But it's basically, I'm saying, you've got pin A and pin B. So in my encoder test, my code, I basically create an A pin and a B pin, and I create an encoder object on that. And anytime I can just ask the encoder for its value. And what the encoder's value returns is the timer counter, which is incremented in hardware. So it's because of the way that we've got the period set and the prescaler and all of that jazz, it basically, this is a 32-bit timer, so it gives me a count, a 32-bit value, an integer, which is the count, and it requires zero. There's no like interrupt callback, or there's no MicroPython code running at all. It's just all running in the timer hardware.
All hardware timer, so there is no interrupts.
Yeah, it's literally connecting these two pins to drive the timer. And then the timer increments, and it knows that it's an AB, so it knows depending on which phase they're in to either increment the counter or decrement the counter based on what direction you're going. So it's dead simple.
Well, thanks for that.
It's a lot trickier if you're doing it on something like an ESP32. If you're using an RP2040, you can create a PIO that will do quadrature decoding, but that requires, I forget whether it's 2 or 4 state machines to handle it, to handle a full-blown quadrature encoder like a 2-pin AB. I know Tom's been playing with that, but he doesn't have a quadrature encoder on his robot. He's got a simpler encoder.
Yeah, you can do it with one state machine. The problem is you will use up 50% of all the available instruction spaces. That's the downside of that one.
Yeah. Yeah, and that's one of the reasons why I chose the STM32 as the main processor on this robot, because I knew before I even started I was going to have a quadrature encoder. I knew I was going to be decoding servos and emitting servo pulse width modulation and stuff, and the STM32 is phenomenal at that sort of thing.
Now, if you want multiple quadrature encoders, the code can be reused. So you can embed one quadrature encoder input connected to each state machine, which allows you to run 8 of them if you want to.
Yeah. Yeah, that's very handy. The STM32 can only handle 2 quadrature encoders with this mechanism, at least with 32-bit timers. You could do more, I think, with 16-bit timers, but you can run out a 16-bit timer on a quadrature encoder in a matter of seconds.
Hello.
Hello.
Where you at?
Oh.
Cookies?
Somebody want to mute Harold?
House?
Yeah, I'll mute Harold.
Okay, I'm not surprised.
He's on the phone. Yeah.
And what flavor of STM32 are you using, John?
It's an STM32 F405. It's the same chip that the original Pi board uses. I can provide a link to where I bought it. I bought like 5 of them off of Alley because they were so cheap. Let me go and.
Sorry, John, I misinformed everyone that I said it was an ESP32.
Oh no,
And
it's an
it's
STM32.
32. I think you said a 405.
Yeah. STM32 F405. Let's find them here. I ordered way too much stuff off of Alley. Okay, here it is. All right, I'll drop a link. So that's what I bought. And there's 3 variants of that, and you need to make sure that you pick the 405 variant. Actually, I guess they've gotten cheaper. It's $8.84 Canadian. Huh. That's pretty cool.
Sometimes I'm amazed what you can get there.
Yeah, and it's like I said, it seems to be a decent quality board, and they provide you with the board file so you can create your own firmware. I actually created my own firmware because I wanted to change one of the default pin assignments, because the STM32 is very flexible about where, it's got multiple pins and stuff for UARTs, multiple choices, and I didn't want I wanted a different choice than what they had chosen as the default. So I made my own firmware, but it's not hard to make MicroPython firmware. So.
Well, thanks, John. Next up, we had Mike.
Okay. Yeah, well, sort of segue off of John. I'm doing the remote control car muxing of the control signals from the transmitter, which is to the engine and the steering and everything, using an RC mux board. And I talked about that last week. But what I realized at the time is it broke the telemetry back to the transmitter. And and so I decided this week to go, to go look on a scope and see what's going on. And so the expectation, well, I didn't know how the telemetry was done. Hold on a second. Something's going on. So I took a scope and looked at it, and when it was hooked up to the transmitter without the mux chip, the steering signal was some kind of a serial interface, a bidirectional. Not sure what the protocol is, but that's how the telemetry worked. Then when I put the RC mux pin in there, first of all, it was a real fast protocol, which isn't a servo style signal, and it's bidirectional, and so it just broke the connection. And when you do that, the RC receiver reverts to a standard servo signal, and so that's how it was working. So right now I'm stuck with the mode where my telemetry doesn't work. I was hoping to use it some more, like it gives me a good thing like battery voltage, but I can get battery voltage some other way. But if I went and did a project like John did and used a microcontroller, I could probably decode and create that serial control and keep the telemetry running, even if I'm controlling it with my computer instead of from the transmitter. But that's a different project. So that's one thing I was doing this week. Then another thing is I decided I need to start working on a computer for my remote control car. And so I looked at it and said, oh, a Pi 5 board, 8 gig, is $5 more expensive than a Pi 4. I should go for the higher higher processing power. So here's my little Pi 5 board here, and it works good. Yeah, as a Pi. But then of course
Sucks down power.
Pardon?
It sucks down power.
Yeah. And so I figured I got power. I got big batteries.
Yeah.
And but then of course using Pi 5, I realized I'd be stuck with Docker, and I really have a hard time using Docker all the way. Trying to get everything to work. But I got Docker on there, and I got an image. Finally, I settled on an image of Ross. And enabled the hardware interfaces. Right now I'm using privilege mode, which is something you shouldn't use, but I just want to make sure my hardware works before I start tightening it down. So it'd say, okay, it works, and if I tighten it down and it breaks, then I know it's just my code, not the hardware or some other weird code things. But one thing I haven't gotten it to work yet is graphics from the like ROS graphics, like RViz and stuff. I haven't gotten that to work in Docker on the Pi, and I'm wondering if it would work better, or it would finally start working, like the graphics would start working if my Pi actually ran off of an Ubuntu image. Like for the Pi 4, for the Pi 5, it's Ubuntu 24, but for ROS, it needs to be Ubuntu 22. And so I'm thinking maybe if I load Ubuntu onto the Pi instead of Raspbian, the Pi OS, the Docker would have better compatibility, i.e., maybe the graphics will start working.
Why do you want to run graphics on your Pi 5?
Oh, well, I want to just see some stuff. I mean, I got some power. And
I thought the whole point behind ROS was that you can run visualizers and things like that on a node like your desktop or your laptop and have the core robot functionality on the robot.
Yeah, but that's not very portable, like when you're in the field running your ROS. I was just hoping to have like a VNC terminal on the phone or something to display some graphics instead of a laptop on carrying a laptop around in the field. So that was my thoughts. And if I can't get graphics to work, then I'm basically stuck with the way I'm doing it for the last project, which is doing everything on a Linux laptop or Linux computer, doing the graphic stuff and over Wi-Fi. So I'm going down this road trying to figure out how to make what I want to do work, even though it's pretty heavy duty stuff. But I got a Pi 5, so I can use some of its extra power to do some graphics. I don't know. So I'm having a hard time getting Pi 5, Docker, and graphics to work. So on ROS. but one thing I did do is when I did privilege mode and set up the host network interface, I could run a publisher on the Pi 5 in Docker on the ROS, and then on my Linux laptop, I could actually echo the topic on it. So it verified that the networking worked, which I was having a hard time trying to figure out verifying that. Because every time I loaded these images, they're really light and they don't even have things like ping on it. And I'm having a really hard time figuring out how to expand it. So I'm coming along on that, and I really want to try to get graphics to work. Another thing I worked on, I was trying to get my Oak D Lite to work for the Moon Day thing. and it's just giving me, it's becoming unstable for some reason. But one thing I tried to do is I tried to put it on the Pi 5, and it seemed like it installed and everything. And then when I wanted to run one of the applications, one of the AI applications with the LoCD light plugged into the Pi 5, running the Python code, it said the Qt subsystem wasn't there or something. So so to do some of their examples, I got to figure out how to enable Qt. But I talked to John earlier before the meeting, and he said that, well, Qt sucks basically. And
Well, I wouldn't say that it sucks. Trying to get it installed and working sucks.
right. Okay, yeah, right. And but he has his Pi 4 working with the OAK-D light, so I should be able to do it on the Pi 5, but he's not using Qt. So the example he ran didn't use Qt, and he based his code off of that. So I need to go find an example that doesn't use Qt and verify that the camera is hooked up to the Pi 5 and it's working the way it's supposed to. So yeah, so that's what I've been working on this week. Haven't been doing nothing.
Well, Mike, so two thoughts, Mike. A suggestion regarding the graphics might be, I don't know if you took a look at the Docker stuff that I did for the ROS 2 workshop, but there was some special funky stuff I had to do, found on the web somewhere, to make graphics work running in the container. But perhaps so you could have a look at the Docker file in there, that. But perhaps a higher level comment is you're really pushing into the edge cases of with what you're trying to do in terms of Pi 5s and graphics inside Docker on ROS graphics specifically inside Docker on the Pi 5, and I think you're kind of asking for trouble in some ways by going into such an edge case.
I agree. Yeah, I agree, and it's something I'm trying to do. I think your stuff wasn't running on Pi's; it was running on Linux WSL or on a Linux laptop. So I expect those to work a lot better. Like one thing I noticed was in the Pi OS, I made sure it was in the X mode instead of the Wayland mode. I thought that was the problem at first, but I still don't have anything called $display, and everything I see it needs a display to work on. So I got to figure out.
That's correct. Do you have a hardware display on the board?
I was just no, it's a headless. I was just using VNC as a display.
Right, and that I've run into that as being a problem because it won't automatically create a display, and I'm trying to think how I solve that.
Is it in your tutorial that you made? I can go. I haven't reviewed through that yet. I was hoping maybe I can go back there and get some nuggets, but
not the specific thing of how to get $display. So actually, there were we did get the Pi 4 displaying graphics on VNC, but there was a trick, and I just don't remember it, on how to get the virtual. You have to get a virtual display set up because there isn't a physical display. and I don't remember if it was a option that you gave to Tiger VNC to use a virtual display. There was something funky I remember about that.
Okay. Thanks, all. Something to bite into. Thanks. And the other thing is just to don't do graphics, but I want to do graphics. I don't know. Silly me.
Yeah, oh, you definitely need graphics one way or another.
Well, on the Pi, yeah.
Or just
Pi
a
Docker.
question of how you go about getting them.
If
Right.
you're trying to run graphics, I believe on a Pi headless through SSH, you can start with the -X, SSH dash capital X, and then your username or through your keyless entry to display through SSH to your other computer desktop. But I'm not sure outside of that. So I've done that to display different things where my Pi doesn't have a screen attached, and I'm not going in through VNC. So I'm just going in through SSH, and I am able to do that through an X session.
Oh, okay.
There's a lot of documentation on that online. If you look up Raspberry Pi SSH-X, it'll tell you how to just set it up.
I'll go look into that. I'm not married to VNC. I'm just used to it. Yeah.
So what it'll do is just display your windows that you're trying to display your graphics on. It'll display your windows across on SSH.
I think
Yeah.
there's a configuration setting you need to set in the SSHD_config in order to get that working. It's called X11 forwarding.
Yeah, X is exactly what it is.
Here, I'll drop a link in the chat.
Thanks, John.
Yeah. So I still got hair. I haven't pulled it all out yet. So I'm doing it. But all right. So that's my update.
Well, thanks, Mike.
Okay. Thanks.
Paul, you're up next. Did you remember what you were going to discuss?
It was really more of a question for the rest of you 3D CAD modeling guys. So I actually completed the training on Onshape and got us and was able to do their exercises that use create parts from drawings and then put the parts into an assembly connected by mates, which let you got different kinds of joints that you can connect the parts with and move them in different ways. But for you guys that use SolidWorks or the various other, I forget the other 3D CAD programs that you guys use, I just wondered something that Onshape provides, and I didn't know whether it was like common among these programs, is it has multi-part. What they call it multi-part studio, but basically it lets you do a sketch and then extrude parts to produce multiple parts from within the one sketch within the part studio. Is that a common thing in these 3D CAD programs?
I don't know if it's common. I certainly use it in Onshape for all of my stuff. When I'm designing a robot, I generally build a lot of it inside a single part studio, and I'll have 10 or 20 or 30 parts of the robot as individual components. Now, I mean, you don't generally build multiple, I mean, sometimes you can build multiple parts from a single sketch, but normally
Yeah.
You know, you'll build a sketch and create a part, and you know, maybe do a bunch of sketches to build that part, and then you'll take a surface from that part and do a new sketch and then create a new part.
Yeah, I got how to do that in Onshape, and it totally makes sense. But when I last showed some of the tutorial stuff that I've been doing in Onshape, some of you guys, like Harold and Doug, were like, "Oh yeah, that's old news." You know, the CAD programs that we use do that, and so I was just like kind of curious about how much of this stuff is common across the industry.
From the way you described it, it's hard to directly relate it to other programs, but the concept of using sketches to generate multiple parts in complex assemblies is not unusual at all.
Okay, generating multiple parts from perhaps multiple sketches that are like within one environment, so that as you change one aspect of the drawing, it can affect multiple related parts.
Yeah, absolutely.
Okay, thanks.
And
just
a
trying to
lot of them will have things where you can sort of componentize the inputs, so like the dimensions can be based on arrays to create variations of parts and things like that as well. So you have a single common sketch that sort of sets up the relationships, but then the geometry can change because the dimensions change according to like an input spreadsheet to create variations on parts. But that's a slightly different thing, I think, than what you're talking about.
But thanks very much. That's just trying to understand this landscape since I'm new to it. Thank you.
I would say that there's pretty close to feature parity across all of the top packages. They each just have sort of slightly different ways of doing it that might be more optimized for some workflows than others. But there's a pretty common set of features across modern CAD programs. The main thing I like about Onshape is that it's you can not like it and you can like it, but it's entirely web based, so you can spin it up just about anywhere, and it's really easy to share parts in the they're pretty open about being able to link to to parts that you want to publish and things like that. But we still stick with Fusion because of the CAM, the integrated CAM that we rely on.
What is that, Kareem?
The machining. So basically we use it to control our CNC. And that's like an extra set of functionality that I don't think that they have in Onshape.
You can get there's add-ons for Onshape that will do CAM, but it's not built into the base product.
And you can always do CAM externally as well, but we have it nicely integrated with our workflow. So it's kind of nice that it was cohesively done.
Yeah, when you got something that's working, it's oftentimes a good idea to go with the working rather than explore the unknown.
Yeah.
Okay,
that's all I had.
Thanks, Paul. Next up, we had John.
Okay, and I was going to mention the Moon Day. I think it's this Saturday. We're all going to be there at 9. I'm bringing a table, brain chairs, and one or two ascension cords. Anything else, Paul, that we can leave? Or does that cover most of it?
I think
Robots,
I've set a script.
lots of robots.
On robots, yes. Still robots.
Lots of robots. If you have any demonstration, like what Mike was working on, that would be good too. I would say, just for anybody who's never done a moon day before, if you have a cart, it's very useful to bring your stuff in a cart. They do have carts there to bring stuff in, but it's like 3 carts for the whole group, for everybody. So if you have a little cart and you can load up your stuff in a cart, you'll find it makes things easier for you.
I have access to a large foldable cart, one of those fabric ones.
Yeah, that's what I've got, Mike, and I'll have it full, and so robots will generally be, unless you want them to be something else, they'll be static displays. Otherwise, they'll be to look at and not for people to touch. And well, you can allow them to touch, but they'll, you're in control of that. We should have tables that are kind of set back that some robots can be put on that they don't. And so that also means that if your robot's not 100% functional, that's probably okay too. It should have wires hanging out of it, but you know what I'm saying. So I'm hoping to bring a couple of I'll bring a line LiDAR demonstration and a small line following demonstration, and maybe what is that? The Microsoft. I think it's
The Connect thing.
Yeah, I might be able to get that to work. I'm not sure. So that means I'm going to have a couple of monitors, and I use for the line one. I use a Windows pad. So I just have it set there. So, and if you can, one thing that's helpful if you can do it is a little card that says something about what you're showing. All right. So that way you get people, they can read the card, get some kind of initially in the proper frame. I like to make tent cards. So I'll take a piece of hardboard. I think they call it hardboard. Thick paper. And I fold it.
Cardstock.
Cardstock, yeah. And fold it in half, and write on that. Or you can take one that's a half of a sheet and fold it and make a quarter, and just title your demonstration and maybe one line of text about what it does.
Are you going to be bringing the big robot, whatever it's called, or not? Right?
I really don't want to mess with it, to be quite honest now.
Well, I can bring that little small one. I had that.
Yeah.
That whenever, so that works.
Yeah. The big one, we found that the hip had a was it the hip or the knee? It was the knee was broken, and we didn't get that fixed. And I don't want anything that's a little shaky.
Right.
Because it is 10 feet tall. So
Like if you remember that little test strip one that I had that was like 4 feet tall, I can bring that. Or 3 feet, whatever size it was.
Yeah. Well, robots are different types, different looks.
Okay.
All we're trying to do is get some people interested.
Right.
And you enter in the back in the morning. Okay. So you don't think you go in the front door. I think you go in the back door.
It's in the back corner.
Yeah, there's a photo on the spreadsheet that I emailed all of the exhibitors of where to enter, and it is around the opposite side of the building from the
Right.
737 plane.
Yeah.
I think it's actually a hangar door.
No, it's a real door in the back.
The
Yeah.
hangar door only
Front
opens
there.
for big vehicles.
Yeah.
So,
And John, Mark Reynolds said he was going to bring some breakfast, kolaches or something,
Oh,
And
wow,
then-
that's fantastic.
and then the Moon Day people are providing pizza for lunch.
Yeah.
Yeah, well, I'm bringing my robot that I didn't win anything on, but I'm just going to use it to show my displays, my time of flight array
That's great.
and Bob
Yeah.
detection.
Mike,
Yeah.
that's a
But it
nice
was-
robot. It's a very nice robot.
Yeah.
That would be a great display.
I don't know if I can get the Oak D light to have an interesting AI on it. So
Yeah, I was hoping you would, so I wouldn't, I initially thought I would do something like that, but to be quite honest, I'd rather work on this, this Microsoft thing, see if I can get that going.
yeah, I'll still work on it, but I don't have high hopes for it.
Okay. Yeah. And,
Thank you all, you guys that are exhibiting.
it's a fun event. And, I think everybody will enjoy themselves. And,
I think Harold said he's going to bring a little robot to drive around on the floor.
okay. Yeah,
Like Jim.
I wouldn't be surprised if Eric, brought his, just drive around on the floor.
Doug, are you bringing like the robot dog, whatever that name is, the pie dog?
He'll be there. Yeah.
I'm going to say something like that would be good. Where the key is we don't want to move too much, but move a little. And
I fixed his gate problem. I fixed his
Harold,
gate
showing-
problem. So he looks a lot better when he walks around.
Robbie will be there. I just got
Yay.
kind of completed, and I've still got some problems with it. I want to change some things, but it's more than capable. In fact, I broke it and had to fix it again. So
Oh,
Robbie
nice.
will be there. I'll have me some logo of myself there.
Yeah.
I've got me some other things going on with the deal, and then if we
Cool.
that off, we got a whole bunch of other stuff going on that I can put in there and make it.
Got to make Roby dance.
See, now, Kareem, why do you got to be, adding on?
I just realized I just have a new Saphiro Bolt. I could bring that little baseball sized one.
Yeah.
Yeah, that's cool.
Oh,
That's
I'm
cool.
planning on bringing. I've got my R2D2. I built at Galaxy's Edge there in Disney World. We can bring that and let the people drive around. I'm about to crack open Zemo tomorrow night to see if the 6-wheeled rover. And I was going to bring Hugo Bot and Hugo Bot's a drive around thing, and the Jim Bot. It does the one trick. It goes forward and rolls backwards.
That's fine. Hey, like I say, Harold, just a lot of different looks. That's what we want to achieve.
with
so
some
many people come here, they all look different and they all do something. And they don't have to do anything. They can be static. Because when those people are all over you, you'll be busy answering questions, and you don't want to be trying to track a robot running around. If you have one that you can do like that line following one where you just sit there and let it run and don't even think about it until the battery runs out and it falls on the floor. That sort of thing, you can just let it run.
or one that just raves or howls, like in case of the dog.
So anyway, it'll be fun. We'll do it. So that's this Saturday in morning. So, all right.
John, do you have anything else to add?
Nope, that was the main thing, just to confirm time and location. And thanks to
I
Brian.
want to thank our glorious leader for all of the extra work he did to get it all set up, because that was great. Thanks, Paul.
And
Welcome.
also, thanks for the
Welcome, Doug.
spreadsheet. That spreadsheet you got sent around on the Google Drive, it's a handy thing, man. That's a real handy thing.
We're glad it's working, and I appreciate you guys going out and putting in the time there. I'd be there if I could, but instead I'm like sitting in some RV park beside a marina, and life's a bit bitch.
Yeah.
Okay, Doug P., do you have anything else to present, or is that it?
Yeah, I have a little something. If you guys will just, I'm going to turn on my video, and if you'll just pin me for a second. Okay. And let me get Mike unpinned. Nope, didn't do that. Okay, here we go. All right, first thing first is these came in.
Oh, yay!
All right, and I was looking at them, and I checked the little QC card, QC code. It works great. Works great. The only thing I kind of question is that for an email, it gives president at DPRG.org. It would probably have been better if you'd said information at DPRG.org or something, because I'm just saying it's a little specific. But other than that, I have no complaints. It's a very pretty card. Okay.
Thanks,
great.
Doug.
And it's the
Glad
same
it came in.
this side, and for me it looks backwards,
good.
but I think it looks right for you guys.
Yep.
Okay. All right, so that's that. Now I'm going to share a little something here. Put on my glasses so I can see. How does this work? Enter screen. Okay. Boom. All right. I ran across a couple of these things. There was a SandSmart did a benchmark testing of the new Raspberry. That's not it. Come on, where is it? The Raspberry Pi AI module, which you can't get, by the way, but you could possibly get one by the end of August. So I don't have an AI, so I can't verify these things, but I can say that the 1.7 and 0.6, which are the this is the Raspberry Pi 8, and this is the Raspberry Pi 4. It's the compute module, but it's similar to the board, and that's about right. And that goes along with our speaker the other day talking about how he had to pause his robot and everything. So with the AI kit, you can get with the 4 compute module, you can actually get 37.5 frames per second. And with the Gen 2 PCIe setting, you get 41. And this was a little surprising. With the Gen 3, you can get 80.7, and which is plenty fast for most. And this is using a YOLO model, so that's a very compact model, but it's pretty impressive. The other thing is, here's their. If you decided that 41.8 was enough, you could lower the wattage a little bit. So this was presented by these guys, and if you want making the next gadget AI boosted RPI for real world applications, if you do that on YouTube, it'll show up. Okay. All right. And they do a few other things, and they also show 2. Again, you can't get it, but it's supposed to be released in the next month. Is a dual channel PCIe connector, dual hat. I guess it's a hat. I don't know, what do they call it on a Pi when it's on the bottom? When it's on the bottom, it's something else. It's a hat on the top, But
The
anyway,
taper? I don't know.
I don't know. But anyway, they now have them 2 channels so that you can have an AI kit and your SSD run at the same time. So that's kind of cool. And then I don't know why this is on there. Hold on a second. I need to find out why that's showing up. Oh, this is the other thing I wanted to show. This is, you've probably gone to this guy's channel, Electron Noob or Electro Noobs. And anyway, he generates this little solder practice board, and he gives the Gerber files for it. You can see it's not tremendously dense, but it does provide a lot of different examples. And he gives you can download the Gerbers free. You can go to JCL PCB and order 5 examples of it for about $5. So I thought this might be interesting to some people. I'm working on my surface mount soldering skills, so this was a timely for me. I was doing some other stuff, so this is the 2 sides of the board. So those are 2 things that I ran across that I thought might be of interest to people in the group. Let's see here. Okay. And stop sharing. All right. And so one of the things that I had to do was, I don't know if you can see this, but you can see that there's an extra set of dual row pins on this TNC4 that attach to the underneath. And maybe you can see it there. So it goes along each edge and along the head, but there's also 2 sets in between, and that accesses a couple of extra serial ports and stuff. Anyway, that's all surface mount, and I got that all taken care of. So I'm starting to proceed with my board. I've been on vacation for the last 3 weeks, and so it's a little hard to get started back into this stuff. But anyway, that's what I had to show. Pat, back to you.
Okay, thanks, Doug. Next up, we had Harold. I don't know if Harold is around his computer.
It was there a while ago.
His display will speak for him.
I guess so. I guess that's it for our list. We can go ahead and go to just open discussion if anyone has anything to say.
I got an interesting email from DF Robot a few weeks ago saying, because, hey, you're a valued customer, we're going to send you our free Fire Beetle, which is a...
Whoa, that's cool.
It's an ESP32C6, which is one of the newer ones. So I said, sure, send me that for free. And they did. So that's kind of neat.
Yeah, that's very neat.
It's huge.
I like dealing with SandSmart and DF Robot. They're both good companies.
Yeah.
Wow, that's cool.
I also bought off of Ali from these guys, Lowland. They make this board called the S3 Mini. And this is an ESP32 S3. It's got 8 megabytes of PS RAM and 16 megabytes of flash, and it runs MicroPython, and it's got the dual row headers. So it's very similar to, so like this is a tiny S3 from Unexpected Maker. So it's a little bit wider than that, obviously, but it gives you a whole lot more I/O for the same kind of setup. So I thought that was kind of a interesting board, and they're cheap.
Mm-hmm. Yep.
That's interesting. It's always good to get some free stuff.
Yeah.
Anyone else?
Oh, there he is. Harold.
Yes, sir.
You're up, Harold.
Oh, I'm up. I don't really know. I mean, I can start talking and not know how to stop. I mean, I can do that. But as far as me being up and stuff, this will be here, and I'll be showing off a little bit. It works off my phone. As far as it's called WLED is the software that's running this thing. There's 2,304 RGB LEDs. Each one of these is a 3D print, and I still got some stuff I want to do because it's not sitting flat enough so you can see some shadowing where I don't want to see it. But this is a pretty straightforward thing. I was amazed how much a little 0.4 millimeters of white plastic surrounded by a bunch of black, how it changes the look of the thing in there. It's pretty amazing. Anyway, it's exposed, so you see wiring and stuff in the back, and it ain't the best job, but it'll work. And like I said, I was planning on bringing. I'm gonna crack open tomorrow night on my stream. We're gonna crack open Zemo and make sure things actually we can drive them around and do some stuff. I like the idea of making cards, of putting all these things up, card placements, and I think it's a really good idea. I'll probably do some of that, but yeah. And as far as robotic stuff goes, I think I put them in the Discord. There was a robot, and this went out to the mail too. That whole the guy that is duplicating the rocket landing on his tripod.
Oh, that was neat.
That was neat. That was a really cool thing. If you haven't seen it, go to Discord, go look it up. And we got it. I think Carl put it out. Carl sent it to me, and I think he put it out in other places too. And the other thing is Rover strikes again for as far as robots go. He has a puzzle-solving robot. He painted it. The idea of the first round, the guy got it was painting wood. Real smart fella. He made it harder than it needed to be, I think, but still he couldn't quite make it work. And then Mark Roper got a hold of it, and he put 1,000-piece all white puzzle together in like 4 hours on the thing. And it involves scanning, pick and place. It's really a neat video on the thing. I think I've shared it around a couple places. If it's not in the Discord, I'll make sure it is Discord before it's all said and done. That was really, really cool. I mean, it's still a robot. It may not have wheels and run all over the place, but it's still a robot to go do things. Right? So I am kind of excited about this Moon Day. Being able to show off what we've been doing, and I was looking and see how well it's going to be, and hopefully it's well received, right? And hopefully have some fun.
I'm hoping we have enough room for all of the stuff we're bringing.
If we don't, that's a good problem to have, as opposed to having the one thing sitting there and like, well, we got more sitting there, but we didn't bring it. We got so much stuff is just kind of set up, and I don't want to say piled up because we don't want to pile up nothing necessarily. But the idea, I'm going to have a few of these things. These are I'm going to have some swag for my channel as I'm there. I'm going to be advertising myself as well as DPRG. This is
So what is that? What is that?
This is, let me make sure I get the line here. This is my kind of the motto here. We make stuff, break stuff, and learn stuff. Put it in order. My Harold Pulcher, which is what I am, is on social media all the time. And I just ordered these from Sticker Mule, and then had them print the front. They won't print the back. It's because, and why do you want to print the back? Well, because this here, you started life as a bevel gear set, and I chunked a bunch of stuff away because I want to have the gear thing on it. Inset this bit of coaster so that I could do this, and got my laser my laser on it, etch the rest of it with a whole bunch more information, cut out the hole here, and I have a little rubberized stuff going around there. And I've got stickers to give away and that kind of stuff. So people want to have stickers and things. And come see me. And so we do some, the idea is throwing off some 3D printing. We did something fun with it. And these were a little bit to make some, I might be a little stingy with them, giving them out. So, and then we just kind of glue them together. And I figured that's not really a robot-y thing, but the stuff we have involves making things, right? And putting things together and all these various skills we use to make some of this stuff happen. And maybe I'm a little bit out of scope on it, but I thought being able to show that off would be a cool thing to show off. I mean, like this thing here, it's cool, right? But we got LEDs and we got, take something that looks like this and turn it into that.
Yep.
I think that's really cool. And because its back is open, you can see the power supply, the ES32 on here and how we've wired it up and all that kind of stuff. So hopefully it's more of a bigger demonstratable thing as we got going along on all this stuff. That was my thoughts on that.
Cool.
And hopefully we don't have enough room for all the stuff.
That's right.
Yeah.
That's the perfect situation. Because you know what? After 7 or 8 hours, there'll be failures.
Oh yeah, there will be.
I know that's hard to believe, but it happens.
Okay. And let me there's somebody else here that I want to give a shout out to because I found out something. And I've been holding on to these forever. And I don't see him. Did he drop off already? He's the guy that does the eyeballs, the moving eyeballs on skeletons.
Oh, he's not here tonight.
He's not here tonight.
Oh, yeah. Like John Goche?
Yeah, John. Yeah.
He's not here tonight.
But see, I've got enough of these LED strips in a different manner to make, this is a 48 by 48. I've got enough over there sitting there just because of how you have to order things to make a 32 by 32 panel. I've got to get some more extrusion and I want to do something a little different. I even got extra ESP32s and all the other kind of stuff. And for the power supply instead of the AC, one of the Robo Columbus, he brought 48 volts worth of 5,000 milliamp hours that are not good enough to power his helicopter anymore. I suspect they're still probably good enough to power me a battery operated 32 by 32 one of these for a decent amount of time. So it's wireless and I don't know, make a backpack out of it or something. I don't know yet. But I've got the basic parts to do all this. I just don't know how I want to package it. And I wanted to give him a shout out, give him a thanks. He's been sitting around on my shelf here since then. I don't know what I'm going to do with them, but now I do.
Yeah, well, those came from Ron Grant.
Ron Grant, okay.
Yeah, they came from Ron Grant. His friend is the one that was the helicopter pilot.
I got you. So see, I would have been thinking the wrong person anyway. So it's a good thing I brought that up in the whole idea. I guess I don't exactly remember where I get everything from. So
yeah.
Hopefully that one's not fat because a lot of the other ones that he had were very fat.
Well, no, I just picked that one up and it has a little squishy to it. So maybe this isn't the best thing, but the idea is still a great idea.
Yeah.
Right.
Just be careful.
Yeah. Oh, yeah. I don't need a fire I can't put out. That's for true. That is for true.
For you guys going to Moon Day, can you grab a couple pictures so that the rest of us can see? Maybe just a few of the
Sure.
display setup you got and the people there for you guys, like everybody from the club that shows up.
Oh, you want a live stream?
I don't know if I want to live stream it, but I just thought it would be just interesting to see a couple pictures. That's all.
Yeah. It's a pretty interesting museum. They've got a lot of strange looking planes and I think.
Well, Matt, we can, we might be able to, we can use this channel at any time. So, we could set up something if you wanted to get like a virtual tour of the place. I don't know how good it'll probably have to work on a phone because I don't know how good the Wi-Fi is.
Remember,
Yeah, I'm going to be tied up Saturday. I have to go pick up my wife. She's camping south of here on Manitoulin Island, so I have to go pick her up on Friday, Saturday.
Oh, okay. Well,
I won't make the meeting. So
okay.
that's why I asked. Just a few pictures.
I'll bring it on camera. So, okay.
Yeah, it would be nice to have a few pictures to put on the web. So, yeah, that's a good idea, Pat, because we don't do enough of that. When we have an event, it's either a video or nothing. And sometimes our videos don't work, so it's nothing. So,
well, when you look back at some of the pictures they had with Robbie the robot that were just recently put up, they were nice to see.
Yeah.
Things from days past. So, it's good to put on the website and have it there.
Yeah, I agree.
Harold, did you have anything else? Were you done?
I am done. I'm having supper now.
Has anyone else got anything to present or mention or questions? Well, I guess that would be just about it then.
Actually,
Oh,
can I ask one final question?
Abdullah, absolutely. If you want to ask a question, go ahead.
Thanks. So I'm kind of starting out, so I'm mostly just kind of taking in information rather than outputting anything. I do happen to have something in the works at the moment, and hopefully I'll be able to present it maybe like next week. But like while I'm taking in information, is it kind of I've been taking like notes as everyone kind of speaks, and I should also kind of mention I really appreciate Pat for kind of just like making these notes on the side to kind of mention where we're at with the meeting. That actually helps a lot with that. Sorry, I haven't really thought about how I'm going to phrase this. I know that the meeting is recorded. Is there some way I can kind of view it at a later date as well? Because that would really help me with reviewing most of the stuff. Like I can only take notes so fast, basically.
Absolutely. These meetings are recorded and they're available on our YouTube channel.
Ooh, right. Okay.
Doug, maybe you can give a little bit of info where we can.
It's the channel. See, I'll put it in the thing. Okay. So it's DPRG clips. So you just go to YouTube and put DPRG clips and you'll get there.
Okay. Yeah, I can find it now. Thank you.
Mm-hmm.
So we record all of these meetings, Abdullah, and if you go to the DPRG clips site, there's all sorts of good information from months back to years back. There's some very good information on meetings, on different presentations that have been done by individuals for the club. And it's a wealth of knowledge.
Yeah, and everything from 2016 is also on the website, and that's where you can get the chat records, like what Pat has been putting in the side. That'll be on dprg.org.
Oh, okay. Well, thanks so much for this. I can definitely like move a lot faster with my learning now. Thank you.
Okay. All right.
Just so you know, Abdullah, these meetings, we hold the Robot Builders Night virtual meeting every Tuesday night at 7:30 p.m. Central Time. And then on the fourth Saturday of the month, and I'm not sure 100% what time that is, the fourth Saturday of the month, they have a meeting. Usually it's an in-person meeting at the Dallas Makerspace.
Okay.
And a lot of times that meeting is also live streamed.
Online. Okay.
Yeah, online. And we can basically, a few of us participate. So myself, I'm from Canada. There's a couple others on the call from Canada. There's guys from all over in the US that we participate sometimes virtually to the Saturday meetings.
Okay. I don't know if I have the links to those. Is it just the same one as this one on Meetup, or is it a different link?
There'll be something on the webpage.
If you go
Oh,
to the
right. That makes sense. Yeah.
We'll
DPRG.org website, under
Uh-huh.
news, I believe they have a list of meetings.
Okay.
It usually shows up just about a week before the actual event, because if we go too far in advance, it buries some of you don't know where you really are in time. So usually we try to keep like what's going to happen in the next week or two.
Sure. I'll make sure I kind of keep up with it like on a more regular basis and every week at least once. Sure. Thank you.
No problem. Was that it for that you wanted to know?
Yeah, at the moment. Hopefully I'll be able to actually present stuff next time, but for the time being, just questions. Thank you.
Well, thank you for your question, and stay tuned to the website and find out about more meetings and more topics on the weekends, our weekend meetings once a month.
Thanks very much. Will do.
Okay, guys, if that's it, I guess we'll call it a night. Thank you very much, everybody.
All right, thanks.
It was
Thank
great.
you. Thanks, everyone.
See ya.